Hello, this is the section 5.4 lesson. In this section we're going to talk about the idea of powers, or also known as exponents, and then the closely related idea of scientific notation. So let's start off with the definition of powers. And so an expression involving powers looks like this. We've got a number a raised to a number b. The number a is called the base, and the number b is called the exponent. Now we should note here that in this definition, this exponent has to be a counting number, so that means it's a positive whole number. Here in a bit we'll talk about the case where the exponent is negative. We could talk about cases where the exponent is a decimal or a fraction, but we're not going to get into that. So a raised to the b power simply means that we take a times itself a total of b times. So let's do a couple quick examples of this. Start off with 2 to the 5th power. So that means you take 2 times 2 times 2 times 2 5 times, and we could do that arithmetic, and we get the decimal equivalent, which is 32. Now here's an expression involving base 10. 10 to the 3rd power means 10 times 10 times 10. And so each time we multiply by 10, we're going to add a 0, and so we have 1,000. Now let's talk about a couple of properties here. And these properties are stated in terms of base 10. However, these properties apply to any base. But the most common base that we're going to use in this class is base 10. So the first property says 10 to the a power times 10 to the b power equals 10 to the a plus b. So when we multiply like bases, we simply add the exponents. Now in the in-class activity, we're going to talk about why these properties are true. Right now we're just going to take them for granted. The second property says 10 raised to the 0 power equals 1. It's a fairly simple property. And then the third says that 10 raised to a negative whole number is equal to 1 divided by 10 raised to the positive whole number. So let's do an example of calculating 10 raised to a negative whole number. And in order to come up with the decimal equivalent of 10 to the negative 3rd, we're going to use this idea from the previous section, where we said to multiply a number by 1/10, move the decimal point one place to the left. So let's take 10 to the negative 3, and by definition, or by that property 3 that we just talked about, this is equal to 1 over 10 to the 3rd power. Well, 10 to the 3rd power means 10 times 10 times 10. Now by properties of multiplication of fractions, we could break this up as 1/10 times 1/10 times 1/10. And then we could think of this as the number 1 times 1/10 times 1/10 times 1/10. And so now by a property to multiply by 1/10, each time we move the decimal point one place to the left. So the decimal place was right here. So we're going to move it 1, 2, 3 places to the left, and there we get our decimal equivalent of 10 to the negative 3rd. Now, scientific notation is a way of writing a really big number or a really small number in terms of powers of 10. So a scientific notation, a number in scientific notation, is a number between 1 and 10 times 10 raised to an integer. Remember, an integer is a whole number, could be positive, could be negative, could even be 0. So it's always a number between 1 and 10 times 10 raised to some whole number. So here's a couple of examples. 1.5 times 10 to the negative, or 10 to the positive 3. So to come up with the decimal equivalent of this, we're multiplying by 10 3 times. Each time multiplied by 10, we're going to move the decimal point one place to the right. So the decimal point was here, and now it's going 1, 2, 3, and so this is equal to 1,580. Here's another example, 2.7 times 10 to the 6th. And so we move the decimal point over 6 places, so 1, 2, 3, 4, 5, 6. And so here's the decimal equivalent, 2,700,000. Now here's another example, 9.98 times 10 to the negative 4th. And so to come with the decimal equivalent, we're multiplying by 10 to the negative 4. So that means we're multiplying by 1/10 4 times. So each time we multiply by 1/10, we're going to move the decimal point one place to the left. So the decimal point was originally right here. Now we're going to move it 1, 2, 3, 4 places over. And so here's the decimal equivalent of this number in scientific notation. Now let's do a couple of examples of putting really big or really small numbers in scientific notation. So here's a big number, 9,780,000,000. And so we want to write this number as a number between 1 and 10 times 10 raised to power. And so we're going to start off, the decimal point is here at the right. So we're going to figure out how many times we need to move the decimal point over until we get a number between 1 and 10. So we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9. And so we're going to have 9.78 times 10 to the 9th power. So there's that number in scientific notation. Now likewise, here's another small decimal. Let's put this in scientific notation. So we're going to move our decimal point over until we get a number between 1 and 10. So we're going to go 1, 2, 3, 4, 5, 6. So we're going to have 4.694 times 10 to the negative 6th. So that's all there is to go between decimal and scientific notation. That's it for this really short lesson. Your assignment before next class is to read section 5.4 from the textbook.